Welcome to our physics classroom and good day everyone. Welcome back to schoolwork and I hope you enjoy your vacation and you are now recharged to study and learn again. Last time we discussed about periodic motion. The continuation of our lesson will be discussed in this week and it has something to do with the illustration here. So as you can see, I have here a string. And then we have here the reaction table. So last time we disregard the oscillation of the spring or we disregard the friction. What will happen to the oscillation of the spring if there is a friction? We know that friction is the force opposing to the normal force. So, ito yung pinaka-kumukontra. So, later on, mapapansin natin what will happen to the oscillation of the force or force from the spring or the restoring force and at the same time the kinetic energy. So let us play this video. Yan. So I have here the reaction table. So that is in equilibrium. Nung nag-move na siya, meron na ngayong oscillation. So makikita nyo na ngayon na meron ng height yung ating equilibrium kanina. Nagkaroon na siya ng wavelength, no? And amplitude. So, mapapansin nyo, bumabagal siya because of the friction. And what will happen to the amplitude? Decreasing. And the kinetic energy also decrease. So, hanggang sa yung amplitude natin, mag-decrease siya na mag-decrease or ma-shorten na yung kanyang length. So, hanggang sa mag-zero na yan. Ayan. So, because of the friction. That is the reason why some oscillation decrease in amplitude because of the friction. And this illustration is the continuation of our lesson. And we called this system na kung saan merong decrease sa kanyang amplitude. Ayan, kung mapapansin nyo sa sample, hanggang sa ayan na yung kanyang amplitude. Kanina, malaki yan. Nung ang oscillation is greater. So, what will happen to the amplitude? It is decreasing. So, it has something to do with our lesson this week, which is damping. Okay. So, what is damping? Damping is a decrease in the amplitude of oscillating system. So, as you can see in the illustration a while ago, there is a decrease in the amplitude of the oscillation ng wave natin kanina. And anong tawag natin dun sa system that undergo damping? And that happens when the vibration of the object continuously decreasing due to friction or frictional effect. We call it as damp oscillation. Okay. So here is the illustration of the damp oscillation. As you can see in the illustration, here is the string and show here the oscillation of the string. So as the string moves, because of the frictional effect, there is a changes in the oscillation of the string. The oscillation of the string tends to decrease its amplitude. So again, to review the amplitude is the height from the crest to the equilibrium position. So I already discussed that last week or last lesson, sorry. So as you can see, so dito sa dulo natin, marireach na maliit na yung kanyang amplitude. So we call it as damp oscillation and that process is damping. Okay. So here's the graph kanina. So if we want to show the um damping in a graph, so it will be look like this. There are types of damp oscillation. So the first one is under damp oscillation. Second one is over damp oscillation and third is critically damp oscillation. So let us define them one by one. So let's start with under damp oscillation. When we say under damp oscillation, the system oscillates with decreasing amplitude until it becomes zero. For you to see how it works, so I have your example. Okay. In this example, as you can see, the system oscillates and then decreasing with decreasing amplitude until it becomes zero or reach the equilibrium position. So that is under damp oscillation. Next is overdamp oscillation. The overdamp oscillation, on the other hand, the system returns to equilibrium without oscillating. So just like in this example, no? Ayan. So, as you can see, the system returns to equilibrium. So, without oscillating. So, walang oscillating na nangyari unlike dun sa ating underdamped oscillation. Okay. Next is critically damped oscillation. So, when we say critically damped oscillation, that system returns to equilibrium without oscillating. So, it is quite similar to overdamped oscillation. The difference between them is that the critically damped oscillation is what? Is faster than the overdamp. No, wala ding oscillation na nangyayari. Magre-reach na agad niya yung equilibrium. Just like, mas mabilis nga lang siya, faster than the overdamp oscillation. So, those are the types of damp oscillation. So, another example, as you can see, the underdamp, so there is a slowing down. So, slow down siya, may oscillation pa rin until ma-reach niya yung zero or equilibrium position. Pagdating naman dun sa ating overdamp, ayan, wala nang oscillation, na-reach niya na agad yung zero or equilibrium position. Same with critically damp. Kaya lang, sa kanilang tatlo, pinaka-faster na ma-reach niya yung equilibrium position ni critical damp or critically damp oscillation. So, mas mabilis siya kaysa dito sa ating overdamp. Pero same sila, without oscillation, marireach na nila equilibrium position or the zero. Ito naman, merong oscillation pero decreasing. So, that is the difference between the three types of damp oscillation. So, let us graph them together. Yan. So, that is the underdamp. So, meron tayo decreasing, slowly decreasing the amplitude. Ito naman, wala nang oscillation, nag-decrease agad yung amplitude, zero na agad dito. So, mas mabilis. Ito yung overdamp, no? Medyo mas mabagal siya kumpara sa ating critically damp, as you can see in the graph. So, combining them together, it will be look like this. So, this one is the underdamp oscillation. And this one is the overdamp oscillation. And this one is the critically damp oscillation. So, mas mabilis. Yan. So, let us have sample of this damping or damp oscillation. The first one is the spring. So, as you can see, the spring of the car suspension is critically damp. So that when a car goes over a bump, as you can see in the example, nagkakaroon ng bumping, the passenger in the car quickly and smoothly regains its equilibrium. So, pagka nag-bump, nakasakay ka dyan sa sasakyan, so mariregain mo ulit yung equilibrium because of the critically damp suspension of the car. And at the same time, that critical damping helps leave the car ready to respond to further bumps on the road, especially kapag maraming baku-baku sa daan, no? So, mariregain natin agad yung equilibrium position. So, that is very important when it comes to car, the critically damped oscillation. Another example is the oscillatory system or oscillatory system like a yo-yo. No? So, sa yo-yo, makikita natin that the vibration slows down and stop over time, corresponding to decrease in the amplitude because of the friction. So, later on, mag-stop yan. Hindi naman siya forever iikot. Pero mag-stop siya, kaya na-enjoy natin yan, and then magpe-play ulit tayo ng yo-yo. Mag-stop siya because of the friction. So, that is also example of damp oscillation. Another one is in the clock pendulum. So, the pendulum's vibration slows down and stop over time, corresponding to decrease in the amplitude because of the some forces. So, as you can see, this one is simple harmonic motion. But these clock pendulums undergo damp oscillation. So, those are example. So, we're done with damp oscillation. Now, let's move to waves, another part of our lesson. So, what is wave? As you can see in the illustration, let us define waves. Wave is a disturbance that travels through space and matter. So, when you disturb a table, you will produce a sound. That is sound waves. When you tap a water, you will produce water wave. So, that is disturbance in a medium. No? So, when we say waves, it transfer energy from one place to another. No? Hindi matter, but energy. So, wave transfer energy. And when we say wave, that is disturbance that travel through space and matter. As we go on, you will understand more about waves. So waves come in many shape and forms. So later on, you will see those shape and forms. While all waves share some basic characteristic properties and behavior, some waves can be distinguished from other based on some observable and some non-observable characteristic. It is common to categorize wave based on this distinguishing characteristic. So because of the other forms of the wave, so they are categorized based on their characteristics. So we have here a diagram that shows the organization of the wave. So I have here a wave. So it is classified into two. So we have mechanical wave and electromagnetic wave. So when we say mechanical wave, it requires medium to travel. Dapat meron siyang dadaanan para mag-travel siya. Pero pag electromagnetic waves daw, they do not require medium. So, hindi niya kailangan ng medium para daanan. Hindi niya kailangan ng solid, ng liquid to travel. So, it can travel without any medium. Yung mechanical wave, this wave needs medium. Okay. So, when we say mechanical waves, it has two. Later on, we will discuss longitudinal waves and transverse wave. So, example of longitudinal waves is the sound wave. So, it needs, alam naman natin, sound waves need a medium, no? When you tap a table, you will produce a sound, no? Speaker, no? Makikita nyo, meron din medium doon. And water wave, of course, ang medium niyan is water. And example of electromagnetic wave, these waves travel without a medium. We have light, microwave, infrared, X-ray, ultraviolet rays, and radio waves. Later on, we will discuss them one by one. Okay, let's start with mechanical wave. So, a mechanical wave is a wave that is not capable of transmitting energy through a vacuum of space. So, kailangan nga ng medium. So, it cannot transfer energy in a vacuum. That is the reason why mechanical waves requires medium, such as matter, like solid, liquid, in order to transfer the energy from one location to another. So, mechanical wave travels in a medium. For you to understand more about mechanical wave, let us have an example. So, first example, we have sound waves. Another one is the water waves. So, those sound waves and water waves needs a medium. So, that's why they are mechanical wave. And we have seismic wave during the earthquake. And we have here the spring wave, and that is longitudinal wave. And we also have the rope wave. So the rope itself is the medium of this kind of wave. So the rope wave. So those are example of mechanical wave. So mechanical wave is divided into two, as you can see in the diagram a while ago. So we have here a transverse wave. So a transverse wave is a type of mechanical wave wherein the pathway or the direction of this wave is perpendicular to the direction of the wave's movement. As you can see, the movement is perpendicular to the direction of the wave movement. So that is transverse wave. On the other hand, another type of the mechanical wave is the longitudinal wave. So longitudinal waves travel parallel to the direction of the wave movement. So it goes like this. So this is parallel and this is perpendicular. So this is transverse wave and this is longitudinal wave. So those are the subdivision or types of mechanical wave. Or mechanical wave travel via transverse wave or longitudinal wave. So this is structure of a longitudinal wave. So we have the amplitude, that is the distance from crest to the rest position or equilibrium position or the source. And as you can see, we have here in a longitudinal wave, we have the expansion and we have the compression. So particles are moving apart. So that is expansion. Magkakalayo. Compression naman, ito naman yung kung saan yung particles are near to one another, no? And we also have the wavelength here. So that is an example of the structure of a longitudinal wave. Another one, we have the transverse wave. So I've already shown you the part of a transverse wave. So we have the amplitude, that is the distance from crest to this one. So lahat tong nasa taas, highest point are crest, and the lowest point are the trough. So here's is the equilibrium position. So this is crest, 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 trough, 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 and we have amplitude here, and amplitude here. So the distance from trough to trough is wavelength. The distance from crest to crest is also considered as wavelength. So these are part of the transverse wave. Okay. So balikan natin yung illustration kanina. We're done with mechanical waves that travels with the medium. And mechanical waves can be classified into two, no? Yung pathway niya can be longitudinal wave, or pwede rin na ang mechanical wave can be a transverse wave. Okay. So let's have electromagnetic waves that do not require medium. Okay, let us define electromagnetic wave. Electromagnetic wave that can transmit its energy through a vacuum or an empty space. So it can travel in an empty space. So such as vacuum. For you to understand it more, unlike the mechanical wave, no, hindi siya nakakapag-travel sa vacuum. Kaya kailangan niya ng medium to travel. Electromagnetic alone can travel empty space. So electromagnetic waves are produced by the vibration of charged particles. And at the same time, if mechanical wave can travel or move through transverse and longitudinal wave, electromagnetic wave travel through a transverse wave. Only transverse wave. So here's the example of an electromagnetic wave. And since electromagnetic wave is a transverse wave or move through a transverse wave, so it has quite similar structure. So we have the wavelength, the amplitude. Hindi ko na siya nilagay kasi na-discuss naman na natin yung parts na transverse wave a while ago and sa ating past lesson. So, let us have example of electromagnetic wave na ibigay ko na rin kanina sa illustration natin sa diagram. Okay, example of electromagnetic wave can be found in the electromagnetic spectrum or the electromagnetic radiation. The first one is the radio waves. So we have the microwaves at the same time. This for cooking. So we have here the microwave oven. So that is also example of electromagnetic wave. And also the waves that we use in television, na, to broadcast radio and television. Yan, sa telephone natin. Yan, so those are also example of electromagnetic wave. The infrared. So the transmit heat from sun fires and radiators. The visible light. The reason why we see everything, we also use this one in our house, no? The visible light. So we have here the Roy G. Viv, the different color spectrum of the visible light. And also the ultraviolet rays, that is example also of the electromagnetic wave. And also the X-ray. So this is used in the field of medicine to see object inside our bodies or our bones at the same time. And last one is the gamma rays used in treating the cancer cells. Okay, since we're done about waves, so we can now proceed with wave calculation. So for us to be able to understand that, we need to have this equation. So, marami tayong equation about waves, pero ito lang muna yung i-discuss natin for this week. So, the first one is basic wave relation. So, basic wave relation, always follow this basic relation. And that is V is equal to lambda multiplied by the frequency. So, where V is the speed or velocity, and lambda is the wavelength. Yung parang baliktad na Y. So, that is lambda. And we have F for the frequency. I've already discussed you about wavelength and frequency during our past lesson. Another one is the angular frequency. So I've already discussed this one. So let us just show the equation because maybe we will use this on another problem. So we have here this symbol. So this symbol W. So that is lowercase omega is equal to 2 pi multiplied by the f, that is the frequency. If frequency is not given but we have the value of the period, we will use this equation. So we have omega is equal to 2 pi over t. Okay. So let's solve problems for you to apply those equations that we've shown a while ago. So here's our first problem. A wave traveling at a speed of 10 meter per second and has a frequency of 2 hertz. What is its wavelength? So if you want to try this problem, okay, you may try to solve this one. Okay, so let us try to solve this one. So let's find the given, required, equation, solution, and the answer. So as you can see in the problem, we have 10 meter per second. So let's put it on the given. And we have 2 hertz. So let's put it on the given part. So that 2 hertz is equal to 2 wave per second. Or pwedeng tanggalin mo yung waves, kaya lang maglalagay ka ng -1 dito. To denote kung second lang ilalagay mo, na ano siya, period form, 1 over 2. We know that frequency is reciprocal of period. And period is also reciprocal of frequency. Okay, kung second, kasi second is a period. By the way, I will give another example regarding that. And then the missing one is the wavelength. So we have here the symbol of the lambda. Equation to be used, so we have V is equal to lambda multiplied by the frequency. As you can see in the problem, the required is this one. So we need to derive this one. So, how we're going to do that? So, we need to both side, divide them. Kung ano yung kasama ng ating missing, hinahanap natin to. So, kailangan divide both side by F or frequency. So, cancel. So, ang formula natin will be lambda or wavelength is equal to V over F. So, substitute na natin to dito. So, this will be lambda wavelength is equal to 10 meter per second. So, that is the value of B and frequency 2 waves per seconds. So, the answer, cancel natin yung seconds. So, the answer would be 5 meter wavelength. Since that is wavelength, length yon, so pwede na nating i-disregard yung waves. Nilagdag lang naman natin siya to show the cancellation of the seconds here. So, here's the final answer. Okay, let us have another problem. A wave is traveling at a speed of 10 meter per second and has a frequency of 2 hertz. What is its angular frequency if the wavelength is 5 meters? So if you want to try to solve this problem alone, you may try to solve this now. Okay, let's start. Let's find the given, the required, the equation, the solution, and the answer. For our given, we have 2 hertz. So let's put this on our given. So we have 2 hertz, and in a period form, since we know that hertz is a reciprocal of period, so we have 2.0 raised to -1. That is also equivalent to 2 cycle per second. So pwede yan para makapakita lang natin yung unit for seconds. And as you can see in the problem, we need to find the angular frequency. Since we need to find the angular frequency, we don't need to use this following given. We disregard them kasi ang kailangan natin mamaya is the value of the frequency. So, let's put our required, the angular frequency. And the equation to get the angular frequency, that is 2 pi multiplied by the frequency. So, let us solve this one. So we have angular frequency multiplied by the 2 pi and 2.0 raised to -1 per second. So solving this problem will give us the answer 12.56 radian per second. So let us round off lang natin. So the answer will be 13 radians per second. So I hope you have the same answer with me. Let us have another problem. A periodic wave traveling in a uniform medium has a wavelength of 0.080 meter. an amplitude of 0.40 meter, and a frequency of 5.0 hertz. A. Determine the period of the wave. B. Speed of the wave. So, if you want to try to solve this problem, you may try to solve it now. Okay, let's start. Given. So, let's find the given, the required, the equation, the solution, and the answer. For our given, we have 0.080 meter as the value for wavelength. So, let's put it on our given. And another one, we have 5.0 hertz as the value of our frequency. So as you can see in the problem, so I use the unit S to show the unit later since we need to find the speed of the wave. So as you can see, that is also equivalent to 5.0 cycle per second. So same lang naman din yan, dalawa na yan. Pero we can express frequency in that form. And from the problem, it says that we need to find the period and the speed of the wave. So since we have two quantities to solve, so we need to require. So let's put A and B. For A, that would be the value of the period. And for B, that would be the speed of the wave. So for equation, since we have two required, so we have two equations. Magbibigay lang ako ng alternative for equation B. So for equation A, the formula to find the period, that is 1 over F. We know that period is reciprocal of the frequency. And for B, we can use this formula. B is equal to wavelength multiplied by the frequency. Or we can also use the other formula, which is the given is the period. So we can use this one. Wavelength over T as the period. So kahit alin dyan will give you the same answer. So let us have two solution. So for solution A, we have T is equal to 1 over F, the value of our frequency, which is 5.0 hertz. So for this, the answer would be 0.20 seconds. So we know that period is seconds. And for B, the speed, I will use this first. So we have 0.080 as the value of our wavelength multiplied by the frequency, which is 5.0 hertz or cycle per second. So the answer would be, wait lang. I also use this another one pala. So we have 0.080 meter over the value of our period. That would be 1 over 5 seconds. So for this one, the answer would be D is equal to 0.40 meter per second. So kahit alin dito sa formula na to yung ginamit natin will give us the same answer. So I hope you got the correct answer. Okay, let us proceed with the speed of a transverse wave in a string. The speed of a transverse wave in a string varies directly to the square root of the tension in the string, and it varies inversely to the square root of its linear mass density. So putting it in the equation, it would be B is equal to directly proportional daw siya sa ating speed, but varies inversely to the square root of its linear mass density. So this is the symbol for linear mass density. So let us put a legend. So D is the speed, mu is the linear mass density, and that is kilogram per meter ang unit niya. And tension is a force, so the unit is Newton. So that is the formula to get the speed of a transverse wave. Since I've shown you the linear mass density, let us define it properly and find out how to calculate the value of linear mass density. So linear mass density is the mass of the string divided by its length. So from the definition itself, the equation would be linear mass density, that is the symbol, is equal to mass per length. So that's why the unit is kg per meter. So let's put legend. So mu is the linear mass density, wherein kg per meter, m is the mass of the string, and L is the length of the string. So that is the definition of linear mass density. So let us apply the value equation that I've shown you a while ago for you to understand it more. So let us have sample problem. For first problem, So let's read it first. What is the linear mass density and the speed of the wave in a guitar string with a length of 0.65 meter and a mass of 3.5 grams when subjected to a tension of 250 Newton? So for this, let us find the given, the required, the equation, the solution, and the answer. So from the problem, you see that the given is 0.65 meter. So let's put it on the given. So that is the value of the length of the string. And another, we have 3.5, that is the mass of the string. So 3.5 grams, so let us convert it into kilograms since we have Newton here. And then we also have another given, 250 Newton, and that is the value of the tension. We know that tension is a force, so let's put it on the given. So the problem wants us to calculate the linear mass density and the speed. Again, we have two missing quantities. So we have A and B for required. So for A, we have the value of the linear mass density. And for B, we have the speed, the value of the speed. And then for this, since we have two required here, so we have two equation. For equation A, that is the linear mass density can be calculated m over length. And for speed, that would be square root of tension over the linear mass density. So let us have the solution. For letter A, substitute lang natin, linear mass density is equal to the value of the mass, which is 0.0035 kilogram. And the value of the length of the string is 0.65 meter. Solving this will give us the answer for A, which would be 0.054 or 5.4 naka-scientific notation times 10 raised to negative 3. And the unit is kg per meter. For B, the value of the speed, so we have V is equal to square root of the tension, and the value of tension is 250 Newton is kg meter per second squared. So, nilagay ko yan para makita natin yung cancellation later on. And the value of our linear mass density, we already calculate this one. That is 5.4 times 10 raised to negative 3. Yun. So, lalagay na natin dito yung linear mass density. And then, the answer would be, for B, would be, B is equal to 215 meter per second. So, makakancel natin kasi yung kg here, and then yung S, yung squared dito. So, matitira na lang yung isang meter and isang seconds. So, yan yung sagot. So, the answer is 215 meter per second. So, I hope you have the same answer with me. So, that is the end of our problem. So, if you have question, just message me in my Facebook account or in our Google Classroom or in our Septo LMS for questions. And then, thank you everyone for the evaluation. It can be found on your Google Classroom. Maybe I will put it on the Septo LMS, but I will assure you that you can find the learning activities for this video presentation in the Google Classroom. I hope you enjoy our class. Thank you everyone.